Okay, well, we will start our actual content. On Friday, we went over this. I don't know, some ideas of the course, and I talked about academic integrity. I didn't get to the second part where I talked about work and life balance and stuff. But I don't know. Maybe I'll revisit it at the end of the quarter, or maybe I'll just link in my Stats 21 class. I did talk about it a little bit. So I recorded that video, and I guess I can link to the last 15 minutes of that video. But anyway, let's go ahead and take a look. And so this, please make sure you read your textbook, okay? And so here, I've linked to it, and again, you can read in your browser for free, or you can pay, I guess, $90 for a paper hard copy, which is not bad either. Oh, also, I want to make sure everybody did receive their data camp invitation and their campus wire invitation. Some students have told me, they were having issues with campus wire, or actually another student told me they were having issues with data camp. So one of the key things is whatever email address was invited, you have to sign up for an account with that email address. And so, I know some of you are using @g.ucla.edu, and some of you are using @ucla.edu. So, check the email that you received, okay, and then check like the headers, the two part, and then just see, did I get the email that ended with @UCLA or @g.ucla? Because they're probably ending up in the same inbox, right? So even if you're logging into like g.ucla.edu, it might be, the email might be addressed to ucla.edu. So just make sure you sign up when you click that link and create an account. Make sure you're using the correct link there. And on Data Camp, you should be able to see the assignments. I don't know what it looks like for you, but on the assignments, I think I assigned 3 chapters. So there's Introduction to R, and I assigned 2 chapters from there. And then there's Reporting with R Markdown, and I assigned 1 chapter from there. And you only have to do the chapters that are assigned. You don't have to do the entire course. If you want to, there's no stopping you, okay? And in fact, Data Camp, it's kind of a premium service. You got to pay normally you'd have to pay $30 a month or something like that. And part of the I guess to support their academic mission, they grant they're granting all of you 6 months of access to their premium content. And so I know well, at the beginning of the quarter things are a little bit lighter, so you have a little bit more free time, but I know things get busy, and so you might not have as much time to go over everything as you might want to, but yeah, it's all there. And if you complete a course, you get a little certificate of completion that you can then link on LinkedIn and stuff, and you can accumulate a big, I don't know, whatever compendium of stuff. Okay. Similarly, make sure you join Campus Wire. Right now there's no discussion, and that's fine because there really isn't a whole lot. But anyway, here's we're taking a look at Chapter 2 from the textbook. And a lot of my examples, or pretty much today's entire lecture, I'm basing off of that chapter here. So let's go ahead and we will we'll enter this. So yeah, before we get started.
Yeah, speaking of textbooks, would you say it's recommended for students to pair textbook reading on top of coming to lecture and then data camp?
I mean, so this is, you'll discover this throughout your life, is there's not enough time to do everything that you want to, okay? There's going to be a lot of stuff and you want to do it. And so you got to figure out, so obviously if you have unlimited time, yeah, read everything and do everything. And I think you'll get more out of it. And so, of course, I recommend reading the textbook, recommend reviewing your lecture notes, recommend doing all of the homework, and then reviewing it again. But yeah, I don't know. You figure out how to divvy out your time, right? And Some people are able to fit more in, and others not as much. So you figure this out. Okay. Anyway, this week, next week, we're going to be spending a lot of time first on data visualization. Okay, data visualization is basically a way to take data and then present it visually. All right, and as simple as that sounds, or as like basic as that might sound, it's actually very important, because our brains and our eyes have the ability to recognize patterns, recognize kind of distances, and we're using different parts of our brain that get activated when we see a visualization. And they reveal certain things that get lost when we read numbers and data, okay? Which is an incredible thing, right? I just have if you think about what you're doing, when you see this slide and you're reading, right? It's amazing that your brain can even do this, right? That's just like squiggles on a page, or not even a page, right? It's just like differences between light and dark, and your brain recognizes, okay, these are characters, and then they put them together into words, and then these words correspond to ideas in your head. And you see, I don't have, whatever, okay. When you see numbers, they activate certain parts of your brain, and you say, okay, I see the number 25, and I know what 25 represents, and I see the number 250, and I recognize what that means. However, when you have a data graphic, that 25 appears as, a location or a bar of a certain height. 250 appears as a location or a bar of a certain height or location, and your brain, it activates a different part of your brain, okay? So anyway, here's a quote. Data graphics provide one of the most accessible, compelling, and expressive modes to investigate and depict patterns in data. And that's true, okay? And anyone can make a data graphic, but my hope is to give you some of the tools and the thinking in order to make good and compelling graphics, okay? And so I'm using examples straight from our textbook. We're looking at the 2012 federal election cycle, okay? So this is, 10 years ago now? So I don't know if you remember what life was like 10 years ago, okay? But so 2012 was a year of a presidential election, and Obama was president, running for a second term, and Mitt Romney was the challenger at that time. All right. There are also races for the Senate and House of Representatives, and then there's political action committees, and there's the Federal Election Commission. Okay, that kind of kept track of a bunch of this kind of stuff here. Okay. Yeah. Politics 10 years ago is very different than today's. It's interesting. Okay. We're not going to cover it today, but a lot of work before you even get to create data graphics. A lot of times you have to just process the data. Okay, you have to compile it and summarize it and do all kinds of things in terms of calculating summary statistics and cleaning it up and whatnot. And we will get to that later on in our course. It's also a very important part. But here we're going to just kind of focus on making visualizations. All right, so here's a question that is a reasonable question to ask, right? How much money did each candidate raise, okay? But this question all by itself perhaps isn't as meaningful as we might hope, okay? Just because there's a whole bunch of weird campaign finance rules, all right? And there's weird rules about how much an individual can give, okay? And there's a cap for how much an individual can give. And then there's can corporations donate money to a candidate, okay? Or can corporations create advertising on behalf of a candidate, but not necessarily, for that candidate, right? So certain, a lot of times political messages you'll see, I'm blah blah blah, and I approve this message. Okay, that's like the candidate's own thing. But then there's also just like other kind of political entities, these PACs that can kind of just say, we need to stop corruption and blah 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 or whatever, whatever they like to say, and they're not necessarily acting on behalf of a candidate, where the candidate's going to come in and say, I endorse this message, but there's clearly a political message and stuff, right? And so it gets a little bit weird, like how much money did candidate raise? So perhaps a better, where should I put my face? Okay, how much money was spent on each candidate? Okay, so because the candidate themselves might not have raised the money, but a political action committee could spend money on a candidate, and so here we'll look at a plot on whom at least $10 million was spent. Okay, and so we look at like how much money was spent on a candidate, and we see this is $0, $100 million, $200 million, and so there was over $270, $80 million spent on Barack Obama, over 100 million, 100 something million on Mitt Romney, Paul Ryan, his running mate. And then there's a few other people that we probably don't know: Tommy Thompson, Richard Murdoch, Josh Mandel, Tim Kaine, George Allen. Tim Kaine might ring some bells because he was a vice presidential candidate for Hillary Clinton. But anyway, over $10 million were spent on these things. Okay, so we go, Obama had the most money. Okay, so the most spending was on Obama, and then second to that was Romney and Ryan, and those kind of make sense because they were running for president. And then there was a bunch of other stuff, and here's like information that you can read up on Wikipedia, but whatever. This is if you don't have time, don't bother. All right. So does this mean Obama raised the most money? Most money was spent. Okay, so here's just a simple graphic that just says how much money was spent. Does that mean Obama raised the most money? And the answer actually is no, because when we talk about how much money was spent on a candidate, the spending can be like supporting or anti. Okay, so a lot of times you'll see advertisements that they don't. It might not be necessarily endorsed by the candidate themselves, right? So like in this case, it might not necessarily be Mitt Romney trying to put down Obama, but it could just be some organization that doesn't like Obama and says, blah 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 blah, and they're having negative campaign ads, right? In California, we're fairly isolated from a lot of kind of political ads especially for president. I think like right now, you see a lot of kind of ads for like maybe proposition this and that, right? And it's like, yes, on what is it? Like online gambling and stuff like that, right? And you have different organizations kind of supporting or against that, right? But if you go to someplace like Florida or Ohio or these key swing states and stuff like that, it's like it's just an onslaught of advertising. They pick up your IP and they go, oh, you're in Ohio, like every single thing on YouTube is going to be every ad there. Okay, but okay. So anyway, so we should include how much money was spent supporting or against. Now, think about how would you display this? How would you display a graphic that includes this variable for how much money was spent supporting or against?
You want us to like shout it out?
Sure, shout it out.
And there was bar graphs that like split.
Bar graph that split. Okay. Yeah. So, and when you split, I think it probably makes sense to either have like a different color or shading or something like that, right? So this is one possible way to display the graphic. And here we kind of, this is what we would call a stacked bar chart, in that it's on its side, but vertically, the red color and the blue color are kind of stacked rather than kind of side by side. You can also split it that way. And what do you notice here? Okay, if we look at Romney versus Obama here, when you look at like how much money was spent, okay, we see that although more money was spent on Obama, it was vastly more like negative and against. Okay, so as far as like money that was spent supporting Obama, it was actually less than the money spent on Romney. And here there was just kind of a lot more like negativity, all right, and things like that. So it wasn't necessarily that Obama had raised more money or anything like that, but just like a lot more was kind of spent against Obama, trying to persuade voters against him. Okay, and so this is kind of this is interesting, right? This reveals a lot of insight that this by itself did not, right? So at first glance, it seems like, okay, Obama had more money, but in this case, we actually realized a lot more money was spent on Obama, but it was, most of it was anti, okay? And actually, in both cases, the majority of money was anti, and actually in all of these, right? So there's just a lot more kind of like negative advertising that seems to be kind of the, I don't know. That's just the state of political advertising here. You know what, before I forget, let me give you your first view quiz answer for week 1 Monday. And the first view quiz answer is the letter D. D as in dog. D as in dog is your first view quiz answer for today. I'll give you answers 2 and 3 later on. Okay, so most of the spending on a candidate is against a candidate. More total spending on Obama, but and if you look at kind of the proportion, we can see, there's a greater proportion of like against Obama than it was against Romney. I don't know, this looks like a 90-10 split, and this looks kind of like a 70-30 split. Just kind of eyeballing it. I don't actually know. Oh, look at that. Okay, actually, I did do the calculations. The percentage of spending against Romney was around 70%, and that against Obama was 92%. Okay. And so including what type of spending, whether it was supporting or against, reveals, some important insight here, okay? Here's kind of another question, right? Did Republicans spend more money than Democrats during the election, okay? Did Republicans spend more money during Democrats, okay? And so this is, I guess, kind of, we're making a few major assumptions here, and we're gonna assume that Democrats will spend money that support Democratic candidates, and they're also the ones responsible for the anti-Republican, okay? And then Republicans will be the opposite. If there's money spent for supporting a Republican, we're going to assume it's by Republicans. And if there's money against a Democrat, then we're going to assume it's from Republicans, okay? And I know that oversimplifies things. Just there's only 2 parties, and there's all sorts of issues with only having 2 parties and things like that. But just for kind of the simplicity, otherwise it gets like too complicated, right? Like, so we have this, okay? We have just kind of total money for Democratic candidates, and then total money for Republican candidates, and this is supporting. So the total kind of Republican money will be the anti-Democrats, pro-Republicans, and total Democratic money will be anti-Republicans and pro-Democrats. These are like other parties. What was the DFL party that was the Democratic Farmer Labor Party, okay? Apparently that they had enough money to kind of show up on the board. But if you kind of just take the total of this red bar and this blue bar, you know, I think even just easily we can see, you know, there's, the total is more than the short, this bar and this bar, right? Because as far as blue, this one's shorter than this one, and as far as red, this one's taller than this one. So if you take this chunk and this chunk, it's going to be less than this chunk plus this chunk, okay? So more spending supporting Republican candidates than there was supporting Democratic candidates, and more spending against Democratic candidates than there was spending against Republican candidates. And if we kind of look at that, we would say Republicans spent more money than Democrats in that 2012 election cycle. And I don't know what the trends are today, but that's what was there, okay? Very little money in comparison spent on other political parties, and so here's you know, one thing that we can do to kind of gain further insight is we can try to break apart this entire spending. Right now, it's just kind of like the entire Democratic Party and the entire Republican Party, money for or against, and we can ask, okay. What if we split this up, okay, versus looking at it just the entire party as a whole? What if we said, okay, well, what if we just looked at the office of president or senator or Congress, I guess, representative or something like that, okay? And so here we have H for House of Representatives, P for president, and S for Senate. And we see some... And so this is just Office of President. This is basically just over here would be Obama and Romney, and then this is like all Democratic House of Representative candidates, right? So there's pop quiz. How many House of Representatives? 435, right? And then a total of 100 senators, and at any given time, about 1/3 is up for election. Okay, so this would be all, you know, however many of the senators, I don't know, you know, usually something 30-something total in any one given cycle. And, you know, I don't know, depending on which season it is, there might be a few Republicans. And then, you know, every election cycle, I guess federal election cycle, all 435 House of Representative seats are up for election. So this includes like all of them, right? And okay, so in total, this is what we see. All right, and so what do we reveal here, right? So looking back at this, we see, okay, lots of money against Democrats versus Republicans here. But if we kind of look at this, we notice that that money against Democrats, a lot of it is kind of based solely around the president, right? It was you know, a lot of money was anti-Obama at that time, okay? A lot of money being spent there, all right? Now, if you look at kind of like for House of Representatives, like this bar and this bar, I mean, it's hard to tell, but they look fairly similar, okay? We can see a clear difference here. And, you know, as far as like money pro-Republicans, you know, and actually kind of in all offices, money pro-Republicans is a little bit more than money pro-Democrats over here. And then here the anti is kind of similar for both, and here the anti for senators is a little bit more than over here, okay? And this is kind of what we see when we're looking at some visualizations, okay? And, you know, again, all of this information can also just be presented with a table where you get, you know, the actual numbers. So some of you might be like, oh, I want to know the actual numbers. And that's fine. But then, you know, one thing about a visualization is just that kind of immediately we can also just the size comparisons here, right? So I don't know what this is. This is probably like if I said approximately how much more money was anti-Obama than anti-Romney, you can kind of ballpark this and eyeball and say, oh, looks like somewhere between 2.5 to 3 times more, this red bar. Whereas when you're looking at the numbers in a table, that kind of difference, requires additional mental processing versus just visually we can kind of spot it, okay? All right, so this, all of this is kind of, I think, revealed here. So for president, the spending against the Democratic candidate was far greater than the money spent against the Republican candidate. For House and Senate races, money spent against Republican candidates was slightly more than the money spent against the Democratic candidates. Sorry. Okay. I think I messed with the microphone here. Okay. All right. This was kind of a narrative going on at the time. I don't know how much you guys paid attention to politics when you were, 9 years old or something. But there was kind of this, there was talk at the time, and this narrative still exists a little bit, but it's just kind of like, did Romney, there was like a lot of money spent against Obama and kind of on behalf of Romney and things like that. And there's kind of this thing like, oh, he just has these very rich Republican, like 1 or 2 donors or PACs or something that's just spending a whole bunch of money versus like, Obama or things. I think, a lot of times you hear Bernie Sanders was saying something similar, and just that like my average political donation was like $15 or something like that, right? And it's just like, but I've got like such broad appeal and support, across the entire nation or things like that. So if everybody's just donating $15 and things like that, versus like 1 or 2 people giving huge amounts of money. And so we can kind of try to create a plot that looks at how many donations were received based on the amount of the donation, okay? So what kind of plot should we use here if we wanted to see how many donations were received based on the amount of the donation? Yeah.
I think like a histogram where you could have like on the horizontal axis the amount of the donation in like ranges.
Yeah.
And then on the y-axis like the count.
Mm-hmm. Exactly. So this is kind of the classic case for a histogram. Histogram on the horizontal axis, or I guess, traditionally on the horizontal axis, you would have the amount of the donation, okay, starting at 0, going up to, I think the max individual, I don't know, I guess up to 100,000. And then vertically, you would have how many people fit within that bin, okay? And this is our histogram. And, along the x-axis, I guess it goes from 0 to 100,000. And I don't know how wide each of these bins are. Maybe like 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I've got about 8 bins between 0 and 25,000. So each bin's probably something around $3,000. And so we've got, and this says 6E plus 0.5, which makes it even harder to read. So this basically means 6 times 10 with 5 zeros, so $600,000, right? So one with 5 zeros is 100,000, and we got 6 times that, so we got close to 600,000, and here we have, 300. So if this is 2E05 and this is 4E05, oh, you can't even see the lines. They get faded out here, but this is somewhere in between, around 300,000, something like that. Okay, and then what do we see? This bar is a little bit taller. This one's a little bit taller than this one, so this is like the next bin, 3,000 to 6,000, and again, I don't really know. Okay, really hard to kind of differentiate. So what's a suggestion? Do you guys have any suggestions for making this a little bit more useful? Because all we're saying is like, okay, by and large, almost all the donations are under what, $3,000. Okay, fine, but that's not very helpful. Okay, so yeah,
Maybe just zoom in on the tail end so they can see the minute differences.
zoom in on the tail end over here.
Yeah. Or
Okay.
Closer.
Or
We could just get the average donation.
average donation. Okay, and how should we calculate the average? Mean, median, mode. What would you suggest?
I would say median.
Mean. Okay. What are I guess here. Let's just pause for a second. This is not necessarily data visualizations. What are some of the differences between the mean and the median? Yeah.
The mean is not outlier resistant. It's like if there's outliers, it's going to skew the mean by a lot, whereas the median is resistant to outliers.
Okay, so that is a key difference, is that when you have an outlier, so an outlier being something, so what would an outlier be in this graphic here?
75.
Okay, 75,000, right? So if somebody makes a donation of $75,000 to a candidate, we would say that's an outlier, okay? Because I think if any of you encountered somebody and you say, oh, do you support a candidate? And they say, yeah, okay. And then financially, yes. How much did you give? And you say $75,000, you'd be like, what? Right? Because that's like, I don't know, a year and a half of out-of-state tuition, or I don't know. That's like your entire in-state tuition, or a brand new, like 3 brand new cars, or 1 really nice car. I don't know, right? It's a lot of money, right? So the idea of like giving that for a political thing that could not work out, might not work out, that's like, I don't have that kind of money, right? So, and even like, I think among college students, if somebody gives like $100, you're like, oh wow, you're like all in, right? So, but 100,000 is like, that's like the, I don't know how much it would register on this thing, right? Because that's like what? It's like 8 meals right there, or 20, or I don't know. No judgment, It could be 100 meals if you really had to stretch it out, right? So, but yeah, 75,000, we would definitely consider that an outlier, okay? And it's kind of hard to see, but there's like I have no idea how many, but this looks relatively similar over here as it is over here. But yeah, okay. So the mean is affected by outliers. So if you have some really big numbers, it's going to pull the mean up, right? So whereas the median is not affected by the outliers in that direction, yeah.
The median also fails to show if it's like significantly skewed. So like for this, the median on both would likely be pretty similar.
Yeah, the median for both could be similar. Yeah, I mean, as far as the graph goes, the median is going to be somewhere in the middle of this first bar and the middle of this first bar. So yeah, showing the summary statistics may not be as insightful here. Okay, one thing. So we would say this graphic is very much skewed to the right. Okay, skewed to the right means you have outliers on the right side, outliers on the very large side. And then you don't, it's impossible to be skewed to the left here, because going to the left would be a negative political donation, which it would be nice if that was possible, right? And we could just pull money out as citizens and say, I don't know, I'll take that money, please. But yeah, no, that we can't do that. So when you have something that's extremely skewed, okay, one thing that we can do is we can transform our variable, okay? And so we can do something like take the logarithm, right? So we can take the log of a number, and that basically turns, so things that, the x-axis is normally additive, each equal space is represents 25,000, additional 25,000, additional 25,000, and a logarithm will turn kind of the equal spacings out to be multiplicative, right? So you know, if you go out a certain chunk, it's like multiplying by 5, and you go out another chunk, you multiply by 5, and you go out another chunk, you're multiplying by 5. So, okay, so anyway, I wrote out some of the problems with this thing. Both candidates have many donations in smaller amounts. The size of the very large donations make the x-axis difficult to read. Part of the problem is that these histogram bins are a little bit too wide, okay, in that we're going from like 0 to 3,000, or I don't actually know, and that's difficult. And the one thing is that having these plots side by side in this fashion also makes it a little bit difficult to compare. So here's another graphic that tries to remedy some of these things. Okay, so along the horizontal axis, now we have a logarithmic scale. Okay, and so with a log scale, you can't actually go to 0, but you know, I don't know what this is, but I think $1. So you got something around $10, and this kind of distance is multiplying by a factor of 100, and then going from here to here, which is the same horizontal distance, is also multiplying by the same factor, multiplying by 100. Okay. And what do you see? Okay, so we see a few kind of key peaks here. So this would be halfway right here would be donations of around, so we go from 10 to 100 to 1,000. So this would be multiplying by factors, if I had another line, a tick mark here would be multiplying by a factor of 10 and multiplying by a factor of 10. Okay, so, and to kind of remedy the issue that we had where we had, it was side by side, we just have two lines that are kind of plotted directly on top of each other, all right? And then to kind of remedy the issue with bins being too wide, we've gone to a density plot, okay? Or a density curve, which kind of just tries to draw a smoothed out graph, right? And so this looks to be, if I had to guess, this might be something around, if this is 100 and 1,000, I don't know, maybe around $200, something around there, okay? And we seem to have a kind of a spike in both candidates around 200, and this is probably a spike around 500, okay? And this is a spike around 1,000. Or maybe it's 250, I don't know. Okay, so if this is the same distance as here to here, times 2, 500 times 2. So, yeah, 250, 500, 1,000 would be kind of my guess. All right, and so what do we see? We see, okay, yeah, you know, as far as Obama goes, there were a lot of people who donated maybe around 250, maybe a lot of people who donated around 500, a lot of people who donated around 1,000, and this would be maybe $2,000, okay? As far as Romney's donations, okay, the spike around 250 is lower. It's still the highest amount, okay, but it's not as pronounced as it was for Obama. And then kind of the spike at 2,000, again, there's still kind of a spike here at around 2,000-ish, but it's, you know, much taller. So as far as individual donations go, you know, you do have more people kind of donating $2,000 to Romney than to Obama in this kind of graphic. Now, as far as people on the right end, the right tail, the line for Romney is just ever so slightly above the line for Obama, okay, with the exception of some kind of small peak here, maybe around 50,000. I'm just kind of eyeballing and guessing, and this is around 10,000. And again, it's kind of hard to draw too much conclusion from this part of the graphic, but basically, the individuals who donate, you know, huge, large amounts, it's there's not too much, although, yeah, the blue line is a little bit taller than the red line here, okay? So, yeah, these are some summaries of some of the changes that we've done. Okay, and so, yeah, it does appear that Romney had fewer small donations and some more larger donations, okay? If we split further based on the phase of the election, the difference goes away in kind of the general election phase. And so this is during the primary part of the election, and this is the general election. Okay, and during the general election, so this is like once the final candidates have been selected, right? So there's the primary phase where, there's a whole bunch of different, at least because Obama was running for re-election, it's not like Obama had like challengers at the time. And so, donations did come in for Obama, but these were kind of who were supporting Romney during the primary phase, and there were a lot of people who really wanted Romney over other Republican candidates, and that seems to kind of follow this trend of like they were donating the $2,000 or whatever. During the general phase, these two lines are very, very similar. Yeah, they're not exactly the same. Okay, you do still kind of see a larger bump for Romney versus Obama here, but these peaks and these trends are very similar during the general election phase. Okay, although you do see like there is a spike for $100 and spikes for I guess 50 or whatever for these candidates. Yeah.
Why does it look like almost nobody donated under $100 to Romney?
I don't know. Yeah, I'm not quite sure. Apparently, in the data set, it doesn't look like there were any donations, which is a little bit surprising. You'd think like at least there's got to be somebody who donated just $100 or something to Romney. So this is it does look like that, and that is a little bit strange, and it could be something like, okay, let me double check the data set, right? This is kind of something where you notice something a little bit strange and you go, let me double check the data set to make sure like I didn't accidentally throw away some data or something went wrong. I didn't do that, so I don't know. This apparently looks, the data set kind of seems to suggest that nobody donated less than $100 to Romney, but that does sound a little bit strange, like, is that really the case? I don't know. Who knows, right? Yeah.
Also, like, what does the density side like really mean? Like, how does it like quantify it?
Yeah, the density is a bit of a strange thing, and I don't know if it applies directly in this case, but in general, the density, the scale of the density is a little bit less important. The idea is that if you were to integrate the entire thing, the entire area under a density curve will equal 1. And that kind of puts things, even if you have different numbers of measurements, like one, if you create a density curve based on 100 observations versus like 1,000 or 1,000,000 observations, the total area under a density curve would be 1 versus a traditional frequency would be based on how many total observations you have.
So why does that just go past 1?
Density curves can definitely go past 1. So that's fine. Yeah, it's not a cumulative distribution function, has a hard cap at 1. That's the CDF, but the density can go above 1. Before I forget, let me just go ahead and give you your last 2 view quiz answers. The last 2, the second one is C as in cat, and the third one is E as in elephant. The second one is C as in cat, and the third one is E as in elephant. Okay. We're going to run out of time. I'm going to start talking about this, and I guess I'll have to continue this in Wednesday's lecture. But we're going to start, as far as visualizations go and creating graphs on the computer and whatnot, we're going to use a tool called ggplot. Okay? ggplot is a package in R and RStudio. Make sure you start doing your data camp homework. We'll give you some base familiarization with R. I've also posted a couple links on Canvas about like downloading and installing R and downloading and installing RStudio. You're going to need to run R and RStudio on a computer and not an iPad or something like that. Okay, and I know a lot of people prefer working on their iPads, and iPads are great, but they're not really designed around like coding. It's a lot harder. It's not impossible, and if you absolutely insist on working on your iPad, come talk to me and we can get you set up with like a cloud service that can help let you run R and RStudio and stuff. But it's a little bit of a pain. So just resign yourself to doing your coding work on a computer. But a key part of ggplot is the GG in ggplot stands for Grammar of Graphics. Grammar of Graphics. And a key and fundamental idea is that we are going to map properties of the data to visual properties of the graphic. Okay? And so one example was we took the size of the donation, okay, which is like this numeric quantity. How much money did somebody donate? Did they donate $100, $1,000, $10,000? And we said, depending on how much money they go, we're going to affect, something on the x-axis. So $100 goes over here on the x-axis. $1,000 goes over, in another position on the x-axis. Okay, and we take that frequency and determine how high or low to make the density curve and things like that. And then what our brain does is it looks at that graphic, and then it kind of goes from those visual cues, and it creates inside your brain it creates basically the data inside your brain. Now, you're not necessarily creating a table of data in your brain, but if you had to, you could. Okay, if you had to, you could. And so we'll take a closer look at this kind of concept here. You can kind of flip through some of these slides. On Wednesday, we'll start looking at ggplot, and we'll start working through some of this stuff. So here are just some kind of concepts as far as what are some of the visual cues. Okay, one is the position. Other things that come into play are the length or the angle, the direction. But our eyes also can take into account the shape of the dots. And so you can imagine some kind of scatter plot where you got points and things, and you can say, okay, the circles represent this group, and the squares represent this group, and the triangles represent that group, right? And then you also have colors, right? And you can say red circles represent this, and blue squares represent something else, and red squares represent this other thing, and stuff like that, right? There's a whole bunch of kind of visual cues that we can take into account. And so we'll see some examples. We'll start creating some of these things. And so anyway, that's all I've got for today, and we'll start creating graphics on Wednesday. All right, see you then. Be sure to take your review quiz, answer your questions, and we'll see you on Wednesday.